Hello everyone, I'm Frank and welcome to episode 37 of Learn How to Sudoku, where we break down very easy variant Sudoku puzzles so that you can learn how to solve Sudoku problems. And I'm coming back from vacation, I got a nice haircut, and I guess I'm ready to go. Anyways, today's very easy puzzle is called Swim Competition Breaststroke by Will Power. And as you can see, we have a little drawing of a person doing a breaststroke down his lanes, it looks like. I'm not sure what these little gray square or these cells which with the arrows pointing out are supposed to be, but very cool drawing actually. It's pretty cool. Anyways, here are the rules. Normal Sudoku rules apply, which means place the digits 1 through 9 once each in every row, column, and box. Anti-king rules. Cells a chess king's move apart cannot have the same number. So in addition to normal Sudoku rules, say for example you had a 3 here, that would mean any digit that is a king's move away, which would be these cells, also cannot have a 3. Now, these could not be 3 because of normal Sudoku rules, but it does include these cells, right, which also are not allowed to be 3. So that's how anti-king rule works. Arrows. Numbers on arrows, and that's for all, for the anti-king, that's for all cells. So every cell has the anti-king rule in effect. So that means no cell can have the same digit being a king's move away from it. Arrows. Numbers on arrows sum to the number in the arrow's digit. The arrow's circle. Numbers may repeat on arrows if other rules allow. Oh, that's very interesting. So this is one arrow. So these 4 digits must add up to what this digit is. Similarly, these 4 digits must add up to what this digit is. And similarly, these 5 digits here add up to what this digit is. And these 5 digits add up to what this digit is. So as an example, this could be something like, I don't know, 1, 2, 3, 1, and therefore this would be 7, because this adds up to 7. 1 plus 2 plus 3 plus 1 adds up to 7. And that's how arrows work. Thermometers. Numbers on thermometers increase from the bulb end. So an example for this would be, 2, 3, 5, 7, 8. And it's always increasing from the bulb to the tip. Now, what could not work would be, for example, 2, 6, 5, 7, 8, because the 6 is decreasing next to the 5 then, which is the next number on the list. Similarly, you can't have 2, 5, 5, 7, 8, because the 5 is not increasing to the next number on the thermometer, which would be a 5. And that's an example of how thermometers work. Remember, they always increase from the bulb to the tip. And that's specifically in this puzzle. Sometimes you'll have something called slow thermometers, but we won't get into that because that's a different type of puzzle. Anyways, that's how thermometer rules work. Crop key pairs. Numbers with a black dot between them are in a ratio of 2 to 1. And not all possible dots are given. So these are called normally black crop key dots rules, because these have a black crop key dot in between them. And they always have to have a 2 to 1 ratio for the digits that are on either side of the black crop key dot. So for example, if this were a 4, that would mean this digit would have to be a 2 or an 8 to be in a 1 to 2 ratio with this digit. And that's how black crop key dots work. Maximums. Cell shaded gray are greater than all 4 orthogonally adjacent cells. So as an example, this could be like, for example, a 7. Let's make it a 7. And this could be 2, 4, 6, and 5, right? As long as this digit is greater than all 4 orthogonally connected cells, which means the cells that are sharing an edge with it, that satisfies the maximums rule set. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, so for me, I always like going with thermometers because it's always fairly easy to see how it can be, what the minimums and maximums can be. So I usually start from going from the bulb to the tip with the minimum values. So for example, this is the minimum value of 1 because that's the minimum value of the numbers in the Sudoku. This has to be greater than this minimum, this cell specifically. So this is a minimum of 2, right? Because you'll always have one cell that's less than it. This cell is always greater than this cell, which is greater than that cell. So it always has 2 cells that it's greater than. So this must be a minimum of 3. Similarly, this is a minimum of 4, and this is a minimum of 5. Now, the thing is, for this has to be a maximum of 9, right? Because everything, all the largest digits in Sudoku, of all the digits in Sudoku, the largest is 9. So this could be 5 through 9. This is interesting because it can be a maximum of 8, but it can't be every digit in between, though, right? This could be 4 and 8. It cannot be 5, though, because 5, is not double of any other digit, and if you double 5, that gives you 10, which is not a digit either. So obviously 5 is not allowed, and 7 is not allowed on this, because again, 7 is not double of any digit, and if you double 7, you get 14, which is not a digit. So therefore, this could be 4, 6, or 8. The 4, 6, or 8 can be with specifically 2, 8, with a 4. The 6 can be next to a 3, and the 8 can be next to a 4 with the black Kropke dot in between them. So this is 4, 6, or 8. This has to have 2 digits which are greater than it, so this maximum is 7. So this could still be 3 through 7. This has 3 digits greater than it, so it's a maximum of 6, so it's 2, 3, 4, 5, 6. And similarly, this has to be 1 through 5 because 5 is the maximum because it has 4 unique digits that it's next to. So we can take a look at this, and it's going to be very similar along this path. And it's actually going to be almost exact. It is going to be exactly the same because, again, this digit, which is the 4th digit on the thermometer, is next to a black Kropke dot, which limits what digits it can be. So this is also 1 through 5. This is also 2 through 6. This is also 3 through 7. This could be 4, 6, or 8, which is next to a 2, an 8, a 3, or a 4. And this is 5 through 9. Okay, where to next? This digit has to be equal to the sum of these 2 digits plus these 2 digits plus that digit at least. Well, the minimum here would be 1 and 2, so that would add up to 3. 1 and 2, that would add up to 3. And 1, 2, or 1 minimum here. So technically, you could have a minimum of 7 here. But the problem is, what happens if this is 1, right? If this is 1, that means this is a minimum of 2. Again, you could have a minimum of 1 and 2 and 1 and 2. But then that would be a minimum of 8. But again, so say you had this being 1 and 2. If this were 1 and 2, that means this could not be 1 and 2 also, right? Because that would eliminate all possibilities for that cell. So therefore, this cannot be 1 and 2 here, right? So if we tried to make this 1 and 2, and we tried to make this 1 and 2, the problem is that this 1 and 2 would eliminate all possibilities for this cell. So at minimum, you have to have one of these be 1 or can be 1 or 2, but the other one has to be at least 1 or 3. So therefore, you'll always have 3 plus 4 at least somewhere here, right? Which means this is at least 7, and then you add 1 to it, so this is at least an 8. So this is at least 8, or it could be 9. It's probably going to be 9 is my guess. Because, yeah, it has to work both ways, right? And one of these has to be at least a 2. So if this is 1 and 3, and this is 1 and 2, and this is 1 and 2, that does actually work, because then this would be 3 and this would be 1. But one of these is a 1, the other one has to be at least a 2. So you would have 7 plus 2, which adds up to 9. So this always has to be a 9, right? And one thing we know, can this ever be 5, right? If this is 5, this is at minimum 3, this is at minimum 3, which would force both of these to be 1. So this set can never be 5 at all. It has to be 4 or less. Right? So again, let me see if I can clarify this. Say this was 5, right? Say this was like, I don't know, 1 and 4 here, right? This is at minimum 1 and 2. This is at minimum 1 and 2. Therefore, this arrow would be adding up to 8 so far, and this arrow would be adding up to 8 so far. The problem is one of these has to be a 1, but then the other one would also have to be 1. And so you would have a 1 and a 1 to add up to 9, which would not be allowed, right? Because of normal Sudoku rules. You can't have two 1s in the same box. So therefore, that shows you can never actually have 5 as a sum of these digits. It has to be 4 or less. So we know the 1 has to be one of these two. And it has to be with 2 or 3. Can this ever be not 1? Sorry, can this ever be... I'm going to pause because actually I need to go to the bathroom right now, so I'll be right back. And I'm back. So let's continue solving this problem. Let's see. Okay. So, right. Can this ever be 1 is the question. Maybe? If this is 1 and this is 2, that would add up to 3. This would have to be at minimum 2 and 3 to add up to 5. This would be at minimum 2 and 3 to add up to 5. So I think the answer is no, right? Say you had this being, again, say you had this being 1, right? Minimum here would be 2 and 3, and this minimum here would be 2 and 3. Therefore, this is minimum of 2 here. So this adds up to 3, this adds up to 5, this adds up to 5. Therefore, you would again have the same problem of this having to be 1 and this having to be 1. So you know specifically this cannot be a 1 here. Therefore, you know this is a 1 because it has to be at most 4, and you can have only 1 and 2 or 1 and 3 be the digits along this arrow part here. This is 2 or 3. If this is 3, it's in a 1 to 2 ratio with another digit. So therefore, this would be 3 and 6. The problem is that this already adds up to 10, which does not, obviously, would be more than 9. And it would never decrease. So this cannot be 3. This has to be 2. which can be in a 1 to 2 ratio with 1 or 4. So this is 1 or 2. The maximum amount this could be, so we have 3. The maximum this could be is 5. So you could have 1, 4 or 1, 3. Either way, you always need a 1 here, right? You can't have 3 and 4 because that already adds up to 10 for this arrow. So you always have a 1 here, which means this can never be 1, which means this can't be 2, which means this can't be 3 because it always has to be greater than these 2 digits, which is never a 1 and 2. Therefore, this can't be 4. This has to be 6 or 8. And 6 or 8 can be only next to 3 and 4. So this is 3 and 4. This can't be 5 or 6 because this digit can never be a 5. And it can't be 4 anymore. So the minimum this could be is a 6, which would make this a 7 at least. And similarly here, this can never be 3 and 4 because then that would add up to 10. So this is either 1, 4 or it's 1, 3. With the 1 having to be here. So this can't be 1. Similar. This is basically almost not symmetrical, but it has very similar logic here. So this can't be 2 because this has to be greater than this digit, which can't be a 1. This can't be 3. This can't be 4, therefore, which makes this a 3 or 4. This is at least a 6, which means this can't be 5 or 6 because they would both be less than this digit then. So this has to be at least a 7. Right. So then this is at least 7. This is at least 6. So this has to be at most 1 or 2. Similarly, this is at most 1 or 2 because this has to be at least 1 and 3. So this adds up to 3 here. This adds up to at least 4. So this is at most 2 here. So we got a 1, 2, 1, 2 pair in box 7. And we number the boxes by convention in typical Western reading notation, which is left to right and top to bottom. So therefore, this box is 1, this box is 2, this box is 3, and this is 4, 5, 6, 7, 8, and 9. And that's just typically how we define the boxes by convention so that we can actually communicate with each other fairly easily. Anyways, I don't know if this is useful right now, so we're gonna just ignore that for now. What about the rest of these arrows? Well, this can be at maximum 5, right? Because if it's 6, that would mean these two digits add up to a minimum 3 because it's 1 and 2. They're in the same box. Therefore, these two digits must add up to a minimum 6. Sorry, at maximum 6. Because 9 minus 3 is 6. So therefore, 1 and whatever digit must be at most 6, which means it has a 3, 4, or 5 there. Similarly, this is also 3, 4, or 5 because of the same logic. Let's see. This cannot be a 9. I'm not sure if we want to go down that way either. So similarly, what can this be at most? Well, this is at least 4. So these two digits must add up to 5 at most. So then it's 1 through 4, and this can't be 1. So if this were 4, this would have to be 2 at least, which would mean this would be add up to 6, but this would be 4 at least, which adds up to 4 plus 6 adds up to 10, which is greater than this digit. So this can never be 4. Similarly, then this has to be 2, 3, or 4. This is 1, 2, or 3. Huh. So, interestingly enough, we have a 2, 3, 4, 5 triplet or quadruplet in row 5, which eliminates 2, 3, 4, and 5 from the rest of the row. So the rest of this has to be 6, 7, 8, or 9 in the row, and this can't be 9, obviously. Well, this digit is always greater than this digit, so it has to be at least a 7, so this is 7 or 8. If this were an 8, that would force this to be 7, which is not greater than it, so this can never be 8. Aha. We now have a 6, 7, 8 triplet in column 4, which eliminates 6, 7, and 8 from the rest of the column. So the rest of the column must be 1 through 5 and 9. This is 1 through 5 and 9, but it cannot contain a 1 because we know one of these two digits has to be a 1 because it cannot be 3 and 4 because that adds up to 10 already, and that would be greater than that digit. So this can't be 1, this can't be 1, and this can't be 1. And there's no 2 allowed because of this 2. So we're limited there also. So this is 7 or 8, which means the digit next to it must be 1 through 7. This can't be 9 because it has to be less than this digit. What else do we know about this? This can't be a 1, because if this were a 1, that would force this to be 3 and 4, which again adds up to 7, which added to 3 adds up to 10, which is greater than that digit. So this can't be a 1. This is 2 through 7. What else do we have? One of these is a 7, right? Because where is the 7 in column 4? It can't be any of these cells because we had the 6, 7, 8 triplet, and it can't be here because this can't be 7 can't be next to a black crocky dot. So one of these two is a 7. Trying to figure out if there's a quick, easy way of doing this, but it doesn't seem like there is. To make things very simple. Oh, anti-king. Huh. Don't know if that helps us much. We know one of these two is a 7. So because one of these two is a 7, neither of these can be a 7, right? Because if this is a 7, by anti-king, none of these can be 7. Similarly, if this is a 7, by anti-king, none of these can be a 7. So none of those can be 7 there. If this is 1, that forces this to be the 1, which means that would be 1. Interesting. One of these has to be 1 and 3, right? One of those is 1 and 3, and then the other one's 2. Sorry. So along this arrow, it has to be 1 and 3 in one of these two pairs. And then the other one has to be 1 and 4 in one of those two pairs. Because they have to be with at minimum 1 and 2. So the one with 2 has to add up with a 1 and a 4 to add up to 9. No, 1 and 3 to add up to 9. And the one that's a 1 has to add up with 1 and 4 to add up to 9. Excuse me. I'm not sure if that's helpful. Hmm. Well, this can never be 1 through 4 because one of these, again, has to be 1 and 3, the other one has to be 1 and 4, and they all are king's move away from this cell. And it can't be 2 because of the king's move away from that 2. Well, it can't be 2 also because of the 1 2 1 2 pair in box 7, which eliminates 1 and 2 from the rest of the box. Therefore, this has to be 5 through 9 here, but that doesn't tell us very much. Okay, I think I see something. Where is the 5 possible in row 5? It has to be either here or it's here. If this is a 5, obviously this can't be any other digit, so this has to be 5, 6, 7, 8, 9. And this can't be any other digit. But what if this is 5? If this is 5, which is the only other possibility for 5 in that row, these two digits must add up to 3, right? Because these already add up to 6. So therefore, this would have to be 2, and this would have to be 1, because this can never be 1 here because of that 1. So therefore, this can never be 2 no matter what. So either it's a 5, or it has to be a 3 or a 4, because the 2 would already be taken here. So this can never be 2, which means this can't be 3, this can't be 4. That doesn't change anything about this, though. Well, can this ever be 4 here? If this is 4, that forces this to be a 3, but that eliminates all possibilities for this cell. This would be at minimum 1 and 5, which would add up to 6 plus 3 plus at least 1, which would add up to 10 for this arrow. So that wouldn't work. So this can never be 4 here, which means this can't be 5, which means this can't be 6. So this has to be an 8, which forces this to be 9, because this is greater. This can no longer be 9. Where is the 9 in column 4? It can only be here. So this is a 9. That wasn't actually very That logic is pretty complex, actually, to actually go there, right? This can't be an 8 anymore, so therefore this must be 7, which makes that a 6, because this has to be lower than this. This 7 means this can't be 7 because of anti-king rule set, so this must be a 6, which forces this to be 5, which means this can't be 5. So this is 3 or 4. This can't be 5 or 6 because of this 5 or 6. We also have a 1, 3, 4 triplet in box 4, which eliminates 3 and 4 from the rest of the box. So this can't be 3 or 4, therefore it must be a 2, which means this can't be 2, this can't be 5. This 8 is in 1 to 2 ratio with a 4, so this is 4, which means this can't be 4. This can't be 2 anymore, therefore this is 1, which forces this to be 2. That means this is 5 so far on this arrow, which means the rest of the arrow has to be add up to 4. So then this becomes specifically 1 and 3, which means that can't be 3, so this has to be 4. This can't be 6 because of this 6, also because of that 6. And this can't be 6 because of that 6. No 6 here because of there. This can't be 1 because of king's move. And in addition, this adds up right now on the arrow to 4. So this has to add up to 5, which makes this a 1 and a 4. So this is 1, this is 4. Because, again, king's move eliminates a 1 there. These can't be 4 anymore. Let's see. The rest of these cells in box 4 cannot be 1 and 3 because we have a 1, 3 pair there. So it must be 6, 7, 8, and 9, but this can't be 7 or 9, so this is 6 or 8. And this could be the full 6, 7 through 6 through 9. Okay. This can't be 4 because of this 4, so this must be a 3. This has to be a 5, which then does force us to be 2 and 1 here. Because this adds up to 6, therefore this can be at least, this has to be at least 3 added up together, which adds up to 9. So therefore this is 1 and 2. This has to be 6 then, because 3 is in 1 to 2 ratio only with 6 as a normal digit. This can no longer then be 6 or 7, because this has to be less than this. This is 4 or 5, which means this has to be less than this. And if it's a 5, it would be greater than or equal to this digit. So then this has to be a 3, which forces this to be a 2. This can no longer be 2, and this can no longer be 3. We know this adds up to 8 because we have a 1, a 3, and a 4 here. Therefore, this digit must be a 1. Because this adds up to 8, that's 8 plus 1 is 9. So that's how that works. Where can 3 be in row 4? Well, it can't be any of these cells because of the 3, and all the other digits are taken, and this can't be the 3. Therefore, this must be the 3 in row 4, which forces this to be 4, which means neither of these can be 4. Therefore, we have a 3, 5, 3, 5 pair in box 2, which eliminates 3 and 5 from the rest of the box, so the remaining cells are 2, 6, and 7. This can't be 2, obviously, because of that 2. The remaining cells here are 4 and 8. So this can't be 8 because we have a 4, 8 pair. This can't be 6 because of that 6 here. Where is the 6 in box 4? It has to be here. So this is a 6. The remaining digits here have to be 4 and 8. So this is 4 and 8, and this is 4 and 8. We have a 4, 8, 4, 8 pair in box 6. So that eliminates 4 and 8 from the rest of the cells in the box. This can no longer be 8. And the rest of the remaining cells in box 6 have to be 5, 7, and 9. Well, this can't be 5 because of King's anti-king rules. So where's the 5 then in box 6? It has to be here. So this is a 5. Let's see. Okay. Where is the 3 in box 7? Well, it can't be here. And it cannot be... Okay, well, actually, yeah, this is a 3 because of this 1. This has to be 1 then. But this 3 means this can never have a 3 in either of these cells because of King's move. And 3 can't be here because of this 3. Therefore, the 3 has to be one of those two digits. And where is the 3 then in row 7? Can't be any of these because of King's move here and because this 3 disallows any 3 here. This can't be 3 because of the thermometer and also King's move. And this can't be 3 because of there. So the only 3 possible in row 7 has to be here. So this is a 3. What else do we have? Who's one of those two? That's fine. This can't be 4 because of this 4. Therefore, this is an 8, which makes that a 4. The remaining cells in column 5 are 5, 6, and 7. That's fine. In these remaining cells, they have to be 5, 6, 7, and 8. But this can't be 8 because of King's move. Therefore, this must be 5, 6, or 7. Well, what is there? Where is the 8 now in box 8? It has to be here. So this is an 8. Let's see. What can this digit be? It's greater than 4 other digits. And the minimum there in the 4 other digits are 1, 2, 4, and 5 because we already have a 3 here. But actually it's 1, 2, 4, 5, or 6 because this is 4 or 5. So this is at minimum 7, 8, or 9. Right? It has to be minimum 7. Interesting. Okay. I'm not sure if that tells us anymore. Where is 1 actually in column 7? It can't be any of these because of anti-king rule, because of this 1. Can't be any of these because of normal Sudoku, because of that 1. It can't be here because of thermometer. Can't be here because of this 1, so it has to be here. So this is a 1. Where is the 1 in row 3? It can't be any of these cells because of anti-king, because of this 1. Can't be any of these cells because of normal Sudoku, because of that 1. Can't be here because this is 6. Can't be here because of that 1, so it must be here. So this is a 1. Which gives us 8 ones, which allows us which tells us where the last 1 has to be, which is here. So this is a 1. Can we do something similar with 2s? Yes, because 2 cannot be here in box 9. 2 can't be here in box 9 because of these 2s. This can't be 2 anymore because, well, that 2. And the maximum rule set forbids this from being 2 because 2 it has to be greater than 4 other cells. Therefore, this is a 2. We don't have any other information though. 3s. This can't be 3 because of King's move. So therefore this must be 5, and therefore this has to be 3. Do we have anything else? The 3 has to be one of these 2 cells because 3 is eliminated that way, here, and here by all the 3s that we see. So it has to be one of those 2. Okay. I don't know if I would consider this an easy solve. Or sorry, a very easy solve. This is probably more along the lines of easy to me. Anyways, one of these has to be a 4 because 4 cannot be here, here, or here by the 4s that we see. 4 has to be one of these two, because these two 4s eliminate these 6 possibilities. This can't be 5 because we have this 5. So this is 6 or 7. So one of these two is a 5. This can't be 1, 2, 3, 6, 8, or 9. So this is 4, 5, or 7 here. Right? And this could be 4, 5, 7, or 8 here, though. We do know that the 8 has to be one of these two cells because 8's eliminated from there and here. This by this 8 and this by the thermometer. This is 5, 7, 8, or 9. But it can't be 9 because of King's move. This is 5, 7, 8, or 9, but it can't be 9 because of this 9. Can't be 8 because King's move from that 8. Unfortunately, that doesn't tell us that much more. This can't be 5 because of King's move from that 5. Oh, this can't be 4 because of this 4 from King's move. So this has to be a 5. Which means this can't be 5, and therefore we have a 6, 7, 6, 7 pair in box 8, which eliminates 6 and 7 from the rest of the box. Therefore, this can't be 6 or 7, so this is a 5. None of these can be 5. We now have a 7, 8, 9 triplet in column 3, which eliminates 7, 8, and 9 from the rest of the column. Therefore, this can't be 7, so this must be a 5. Now, where is the 5 in row 9? It can't be any of these cells because of the 5s in those boxes, respectively. Therefore, it must be one of these two cells. Well, we also know a 3 has to be in one of these two cells, so that forces this to be a 3, 5 pair, because those are the only places for 3 and 5 in row 9. So that eliminates 3 and 5 from the rest of the cells in the row, so this can't be 5. This must be 4, 6, or 7, and this must be 4, 6, or 7, because those are the remaining digits that are possible in row 9. Well, because of that, we know the rest of box... the rest of box 9 cannot contain a 4, a 6, or a 7 because of the 4, 6, 7 triplet in it. So this can't be 4, 6, or 7, so this makes this an 8, which forces this to be 9 because it has to be greater than the 8. This can no longer be 7 or 8 because of the 6, 7 pair in row 7 and the 8 that's there. Therefore, this is a 9, which forces this to be 8, which forces this to be 7. This is forced to be a 4 because of what's left in row 7. This has to be 6 or 8. And this can't be 6, therefore that forces this to be 8, which makes that a 6. This can no longer be an 8 because of this 8. This can't be a 6 because of this 6. Let's see. This can't be 5 because of this 5, therefore this must be a 3, which makes this a 5. We have 8 5s now, which means we know where the last 5 has to be, which means it has to be here, right? Because it's eliminated here, and eliminated here, and eliminated here, and here by all the 5s that we have. What about 3s? Okay, in box 1, we've eliminated all these cells because of this 3, and this can't be a 3 because of this 1. So this is the only place left in box 1 to have a 3. So this must be a 3, which means this can't be 3, and therefore this is a 3 as the last remaining 3 in the grid. Remaining cells, this has to be 7 or 9. because those are the remaining digits in column 1 left. But this can't be a 9, therefore that forces this to be a 7, which makes this a 9, which makes that a 7. And therefore this is a 9, therefore that's a 7. That's all by normal Sudoku rules. This can't be 7 then, because of this 7. The remaining digits here are 2, 8, and 9. But this can't be 9 because of this 9. This can't be 8 because of that 8. And this can't be 2 because of the king's move. So, that doesn't tell us too much, though. This can't be 7 because of this 7. What are the remaining digits here? They have to be 2, 4, and 7. So this is 2, 4, 7. This is 2, 4, 7. But this can't be 4 because of this 4. This can't be 7 because of this 7. Well, we have a 2, 7, 2, 7 pair in row 3, which eliminates 2 and 7 from the rest of the cells in the row. So we only have 8 and 9 possible for the last remaining cell, but this can't be 9 because of that 9. Therefore, that forces this to be 8. This can't be 8 anymore, which forces this to be 9, which makes that a 2, which makes that an 8. This can't be 8 because of this 8, so this is a 4, which makes that an 8. So this can't be 4 anymore. The remaining cells here are 4, 6, and 9. Well, this can't be 9, and this can't be 9, obviously, so the 9 has to be here, specifically. And this could be 4 or 6. This has to be 6 or 7. And now we're just probably looking for... what are we looking for? Probably king's move, anti-king. I don't see very... well, I do not... Yeah. Anyways, let's just finish this off. Okay, let's start coloring the 6 sevens. We're gonna make this pink and this yellow. So that forces this to be pink. Yellow's one of these two. Unfortunately, we don't... this can't be pink. Okay, well, there you have it. I'm not used to seeing anti-kings moves, so it's really... it's hard for me to spot. But this can't be a 7 because of the anti-king here. So this must be a 6. Which makes that 7, and then everything else should be from Sudoku. So this can't be 6, this is a 2. This has to be 7 then. This is 6, which forces that to be 7, which makes that a 2. Which makes that 4, which makes that 6. Which makes that 4, 7, and that's a 6 by Sudoku. And that's how you solve it. Yeah, maybe it's because I'm not used to the anti-king rule set. But I would not consider this very easy. I would consider this more along the lines of an easy puzzle. Because, I don't know, maybe it's just because I'm not used to anti-king rule set. Anyways, I hope you enjoyed this episode of Learn How to Sudoku. And I'll see you next time on Frank Puzzles. Take care.